For years, science has tried to answer one of the most difficult questions that exist: how life first appeared. Now, an international team of researchers publishes in ChemSystemsChem a proposal that changes the starting point of the debate and shifts the focus to simple, discrete, and hitherto unconsidered materials. If you're interested in the origin of life and want to know more about this fascinating subject, don't forget to subscribe and like this video. Your support is essential to keep creating interesting content. The key would not be in the first cells, but in what happened before they existed. Life's origin remains a puzzle without a definitive solution, despite advances in chemistry, biology, and geology. Scientists know that the molecules needed for life could be formed on primitive Earth. However, explaining how they went from being dispersed to organizing in functional systems remains the great challenge. Many hypotheses have focused on the role of specific molecules, such as RNA or proteins. However, they often set aside the physical environment where these reactions occurred. The new study argues that this environment was not irrelevant, but decisive. Researchers suggest that it could act as a silent facilitator of the process, where chemistry alone would not have sufficed. The team proposes looking beyond the classic scenarios and considering common materials in prebiotic chemistry. Instead of looking for the origin of life in extreme places, they suggest observing simple surfaces. Prebiological gels are semi-solid materials that can trap water and molecules inside them. They acted as small platforms where molecules were retained, thus concentrating what was necessary for life. These gels could be formed naturally on the surface of rocks using compounds available on primitive Earth. Their stability was crucial to allow certain reactions to be repeated and perfected. One of the central ideas of the study is that chemical evolution could begin long before cells existed. Gels would have acted as an intermediate stage between prebiotic chemistry and cell biology. This approach makes it possible to explain how more organized systems emerged without the need for complex structures from the beginning. The compartmentation could exist first in a physical and non-biological way. The study not only explains what may have happened on primitive Earth, but also expands the debate towards the search for life on other planets. Extraterrestrial life may not look like anything we know.